Mars, our planetary neighbor, is a world of fascinating extremes, but one of its weirdest features isn't actually on the planet, it's circling it. Unlike Earth, which has one big round moon, Mars is orbited by two tiny, lumpy companions named Phobos and Deimos. Frankly, they look more like beat-up asteroids than proper moons, but their orbits, nearly perfect circles right above the equator, just don't fit that story. That perfection is a huge clue, one that points to a far more violent past. So, where did these oddball moons come from? It's a cosmic detective story with two very different suspects, and for decades, scientists have been trying to figure out which one is the real culprit. Back in 1877, when American astronomer Asaph Hall first spotted them, he named them Phobos and Deimos, after the Greek gods of fear and terror, the mythological twin suns who rode into battle with Ares, the god of war. The names fit perfectly because these moons are deeply strange. Phobos is only about 22 kilometers across, and Deimos is even smaller, at just 12. They're lumpy, potato-shaped, and pockmarked with craters. They're also some of the darkest, least reflective objects in the whole solar system. Because they look so much like the carbon-rich asteroids you find out past Mars, the first and most obvious theory was simple. They must be captured wanderers. On the surface, the captured asteroid theory makes a lot of sense. The idea is that, long ago, Phobos and Deimos were just a couple of asteroids minding their own business in the asteroid belt. Something knocked them off course. They drifted too close to Mars, and the planet's gravity snagged them, turning them into moons. This would explain why they look exactly like asteroids, because the asterisk would be asterisk asteroids. Their dark, dusty surfaces are a great match for what we call C-type and D-type asteroids. But there's a huge problem with that otherwise neat explanation, and it all comes down to their orbits. When a planet's gravity captures a passing object, the resulting orbit is almost always weird, lopsided, and tilted. Phobos and Deimos, however, travel in neat, orderly circles almost perfectly aligned with the planet's equator. The odds of Mars capturing not one, but two asteroids into such tidy orbits are astronomically low. It'd be like rolling snake eyes 100 times in a row. For years, that glaring contradiction had scientists stumped and forced them to look for a much more dramatic explanation. This brings us to our second suspect, the giant impact. This theory suggests the moons weren't captured at all. They were born from Mars itself. The story goes that early in its history, a massive object, maybe a protoplanet a third of the size of Mars, slammed into the young planet. That cataclysmic smash-up would have blasted billions of tons of molten rock and debris into space, which would have formed a massive ring around Mars. This idea is really appealing because a debris ring is the perfect place to form moons with the exact kind of circular, equatorial orbits we see today. As all that stuff circled the planet, it would have slowly clumped together into one or more moons. In fact, that's the leading theory for how our own moon formed from a giant impact with Earth. But this theory has its own big problem. If Phobos and Deimos were made from a chunk of Mars, they should be made of Martian rock. And as we know, their composition looks a lot more like an asteroid's. So we're left with two theories, where each one perfectly explains one piece of the puzzle while completely failing to explain the other. For a long time, the scientific community was at a stalemate. Do you trust what their orbits are telling you, or what they're made of? But recently, powerful computer simulations have offered a third option, a hybrid theory that might just solve the whole thing. These new models suggest that maybe a single large asteroid didn't get captured, but instead flew too close to Mars and was ripped apart by the planet's gravity. The shattered fragments would have then formed a temporary debris ring, which could explain both their asteroid-like composition asterisk and asterisk their stable circular orbits. It's a clever idea that connects the dots between the two older theories. So, what's the final verdict in this cosmic whodunit? We have two classic suspects, the captured asteroid and the giant impact, and a compelling new hybrid theory that seems to combine the best of both. But science isn't about which story sounds best, it's about hard evidence. and we're on the verge of getting the evidence that could finally crack this case wide open. The Japanese Aerospace Exploration Agency, or JAXA, is preparing the Martian Moon's Exploration MMX mission. Scheduled to launch in 2026, this probe will travel to Mars, land on Phobos, scoop up samples from its surface, and bring them back to Earth. Once scientists get those samples into a lab, they'll finally know what Phobos is really made of. We'll know if it's a captured asteroid, a piece of Mars, or something else entirely. This mission promises to finally solve the strange and captivating mystery of Mars's 2 tiny moons. If you want to stay updated on this cosmic detective story and other mysteries of our solar system, make sure to subscribe and ring the bell for future updates.